Welcome to Code of India. Today classes is about heat energy. We learn about heat and energy conservation. You know the law of conservation of energy. Then what is heat flow? It's same like a water flow. The water flow from higher side level to lower side level. It's simple, the pressure application higher side against the gravity, water flowing to H is the factor. Similarly, in heat, temperature is the factor. This flow direction is from higher temperature to lower temperature. So, suppose this red color is high, more heated, the temperature here is high, and these are in contact with this cold blue color element. Due to this gradient of the temperature, the heat starts to flow from higher to lower temperature, just like the water flow. So if something warm in contact with the something cooler, the warm thing cools down as the cool thing gets a little warmer. When heat will transfer, it will become little cooler as compared to as it was before heat will transfer to place, and it becomes little hotter, and the flow will continue till the equilibrium took place. It's same like water too, you might have. So this flow energy is called the heat. And this was not a crazy idea using the fluid flow equation. We are considering fluid flow at a particular temperature. Under few circumstances, we can get the fluid flow behavior. What is the temperature? Heat flow in art, inverting Fourier series to do it. Inventing the Fourier series. Is a Fourier series of multiplying factor of the equation. Then what is the flow rate of heat? And what is the flow time from this portion to this portion? Try to understand it. The flow rate will certainly high when the heat difference is high from cold to hot. But after passes a few time, the difference reduced. The flow rate reduced. And the last time when the both of material are going to coincide for the state of equilibrium of temperature, at that time the flow rate is almost nearly zero or ultimately zero. That's decrease in rate of this domain. Different domain of flow rate and flow time we calculate. That is well defined in that series, Fourier series, that we learn in detail in due courses, and we will learn elaborately in the different field of electronics and communication engineering, in mathematics of engineering and BSc mathematics honors engineering, and computer science also is applied. Okay. and there is existed at least one invisible fluid, that is electricity. The idea was that temperature acted like a potential of caloric fluid. The water is just 8 feet high. The potential of the water is the total mass of the water, and the gravity is height. If H will increase, the water potential to flow will more. Because if you consider that quantity of water, M is a constant and G is also constant, that the potential energy flow of the water downward toward the ground, if it is vertical, is more with the height. So that is a caloric fluid in the heat, that is called the caloric fluid, and flowed downhill to tower T. Clear? So let us consider a theory about how to define it in a very simple way. If you believe that the things only rise in the temperature when the something fluid flow in, it is hard to account for the sudden rise in temperature of gas in an insulated no heat flow possible. Container, when it is suddenly compressed by a pushing to downward, when compressed, the caloric fluid does fine in carrying the heat source. Even in the complicated shape, but the break down when the work is done. What work have done? That suppose this volume is now before compressing is V1 and after compressing is arrive here and the volume become V2. Now what's volume it is compressed? Is compressed this volume. Okay? That V1 minus V2, that is a work. Okay? So it is same like the analogy. The spring force is directly proportional to the distance of that spring pulled, extended. Okay? And that is a distance. The force is, the spring force is directly proportional to distance travel. Due to spring, mass was here, and due to spring, it pushed that distance. Then that force should be restored. Same analogy, how that heat of high potential caloric potential will force toward the cold area, and this is work as the energy transfer. The spring does work on the mass and the spring lose potential. When it works, when spring was pressed this position of mass, then spring was in potential. I pressed it at that force. What force I applied? That I have calculated. After releasing this mass of that block, it will push with the distance of x, and that we understand that spring force is how much? Minus kx. Minus here is the analogy, and k is the spring constant. When f directly proportional to x, then k is the spring constant, is a property of the spring. property spring depend upon its diameter, material, its shape. Okay? The manufacturer are making the spring with defining this property. When we will get any problem for this, in problem we will get the value of K. But this minus is here for your vector analysis, for your direction purpose, not for your mathematics purpose. Okay? Don't take it value numerically to calculate the value of F mass into acceleration equal to force. So the heat flow is another form of energy transfer. We have seen in the hotter gas has more kinetic energy per molecule. The hotter gas has more kinetic energy of molecule. We calculated earlier. Okay. So since heat flowing from the hot body to cold body is just a transfer of energy, that is kinetic energy. The natural unit, that is joule, that is work done. It is transferring much means what? There is a work done. Suppose this is the petrol engine, this is your car. Say, this is your car. Say, this is the cylinder of your car engine. Okay? And this is the piston. This is the ignition spark, petrol spark. And this is the inlet valve and this is the outlet valve. Say this piston was here, after certain time this piston will come here. Then how many volume of that? It is compressed. It is compressed. Previously it was V1 and already how much? It was V2. Then work done to how much? V1 minus V2 is work done. And that is defined by the joule. You know the work done is what is joule. Newton meter. And you can that joule, the kilojoule is often convenient unit because this value you can make it from kilojoule divided thousand. The whole unit is calorie. Heat needed to raise the temperature from. So when it is compressing, the piston. Okay, the piston when going backward. Then air intake took place, cylinder will get the air from outside to the air filter of the car. After that piston starts to move inside, then air is compressed. Due to compression of air, the temperature inside this chamber of the compressed air becomes so high that if at that time any fuel is injected from here, the temperature inside that air is so high as it is compressed that it will sufficient to put fire. When this will took fire due to high pressure and temperature, due to spray of the petrol here, explosion took place. And due to explosion, piston will push backward. That is also work done by the force of fuel energy, petrol energy. So water, so calorie you use, food level, we are doing the kilocalorie. You are walking, we are exposing our calorie. That is our work done. We are consuming food of that calorie. And in the BTU 1 lb of water by 100 degree Fahrenheit. Okay, this is calorie conversion of the health. So Joule heat things up. What do you think? That Mr. Joule, James Joule, an English, measured the fractional heat generated by a major amount of work. A falling weight rope paddle under water is insulated can. This result is called the mechanical equivalent of heat. 1 cal equal to 4.19 joule. That is the point to be remembered. You can keep this value every time. That how to cal unit will convert it to joule unit. 1.19. Clear? So the kinetic energy is half mv square by v is the average value, that v square at that mv is the PV. What was the energy? Then P1 V1 at the piston. At that piston, when piston was here pressure was say Vp1. Okay, and here pressure was say P2. Okay, then P1 V1 P1 say minus V2 P2 is the work done. Okay, that is understand? 21. Clear? Both the thing have subtracted on left side and right side. So what we are getting? That is equal to mv square kinetic energy. What is this? Kinetic energy, half mv square equal to 3/2 kT. Okay, that you have defined earlier. Understand? So the change of rate of temperature is what? A small change of temperature. So a specific heat, solid and liquid, there is a per unit mass. There is a heat, say C is the what? Per unit mass. Okay. As amount of heat energy that must be supplied to raise the temperature of 1 kg by 1 degree centigrade. So it is defined by what? This is the heat energy. This is the heat energy. Heat energy. Understand? And what is C? Equal to Okay. If where M is 1 kg and change in temperature is 1 degree, then what? Then C equal to Q. Okay. When the mass is 1 kg and temperature change is 1 degree centigrade, then what will get? C equal to Q, because this side will be 1. So definition is very simple. It's not so hard to learn like a shouting. Mathematically, you can define to be sure. The almost all solid and liquid C can be taken as a constant. Certainly, for wide range of temperature ranges, but it changes dramatically when the substance melt or boil. Basically, the curves are like this. Say this is the temperature, this is the temperature, and this portion is almost linear. Okay. So the melting boiling point, and in between here, this portion is linear. Near to melting point, near to boiling point, it is called linear. This portion is linear. Okay, that is defined. Okay, undoubtedly, water has a very high specific heat. That is why we are comparing everything with the water. The relative specific heat. This liquid, oil, what is its relative specific heat? We compare with the water. Okay? Then water becomes the reference value. In 1820, these two professionals in France, atomic weight into atomic heat, was almost the same for the many different elements. Almost same. Lead 26,000, zinc 25,400. Okay. Within that 1,000 values, they are almost same. The mercury 28,000. We can now see that means that the peak heat per atom is almost the same as the ideal gas. Elements with heavier atoms have lower peak heat per kg. Because there was a pure atom in the one case. Clear? So this is the question that I have a 100 cc of mercury at 20 centigrade in an insulated container. I pour 100 cc of water at 100 centigrade. Okay. What is the final temperature at thermal equilibrium? Solve it. Come in next class. The calorimetry. Two or more objects we'll discuss tomorrow. Okay. Thank you.